Hi guys, welcome back to Algebra. This is, if I'm not mistaken, my first video dealing with Algebra 2 material. Very exciting stuff. So the reason I'm making a video about this topic, well, I feel like I should introduce the topic first. So this video deals with dividing polynomial functions of varying degrees. So we have this right here. We have some polynomial with the second degree on top. This is a quadratic. Anything with the second degree is going to be a quadratic by default. And then we have just a simple linear first degree binomial on the bottom. And the reason why I wanted to make a video like this is because a lot of my Algebra 2 students are getting ready for finals. They are studying really, really hard. A lot of them feel like they need a little bit more review on not only this topic, but another topic similar to this one, which happens to be, well, this one is going to be dividing polynomials by long division, and then the other one is going to be dividing polynomials by synthetic division. So, like I said, they just requested videos like this because they need a bit more practice, and I'm happy to provide. So what the heck are we even supposed to do here? By this point, we're pretty good at dividing numbers. We know, for example, that 10 over 2 is the same exact thing as this long division problem. Easy. But the heck are we supposed to do when we have a function divided by another function? There aren't any explicit rules to tell us how to do this like there are for numbers. So, and you might be even wondering why it's important to know how to do this. Well, to be completely honest with you, most of you guys probably aren't going to use this when you get to your professional life after college. But if you want to study to become a scientist or an engineer of some kind, you're going to be asked to do really complicated things with rational functions. Like, for example, you're going to be asked to take the integral of a function in a calculus class, or you're going to be asked to perhaps take an inverse Laplace transform of something like this in maybe your first year, first order ordinary differential equations class. And it just so happens those operations become much, much, much easier to do when you have a simpler expression. And what do I mean by simpler? I mean, instead of having one big monolithic thing, I'm talking about something like this. And I know the thing we're looking at right now won't really have this form, but I'm using this as kind of an abstract example to describe why it's important to know how to do this and why it's worth your time to learn. So these are all random, by the way. All the letters, all the variables, everything here I just wrote on the right side of the equal sign is completely random, but I'm using it to illustrate what I consider to be a pretty important point. So those operations I mentioned before, they're just two of many, the integral, the inverse Laplace transform. They're, oh, hang on a second. I want to turn my fan off. I do apologize. That was really unprofessional of me. I'm still not used to this new apartment, so apologize for that. So I was saying that those two things I mentioned earlier, those two operations, the integral and the inverse Laplace transform, they're just two of many, many operations of that type, where in general, it's just easier to do those operations if you have a bunch of small expressions that can be dealt with individually instead of one big expression. So we've covered the what, we've covered the why. Now let's cover the how. How do we break something like this up into smaller parts? So it's always worth your while to see if there's an easier way to do things. It's always worth your while to see if there is a way that saves you a lot of time. So for example, I want to do this two different ways. I want to first simplify this expression by factoring. So if we factor our numerator, we're going to get x plus 2 times x plus 5. Over a denominator of x plus 5. I'm going to put the bottom in parentheses for the sake of uniformity. So we can clearly see that when we divide a common factor on the top with a common factor on the bottom, we're left with something much, much simpler and much, much easier to deal with. So if I was sitting in a differential equations class and the professor asked if I'd rather do a Laplace transform of this or this, I'd pick the one on the right every day of the week. I'd always go for this one. It's just much, much easier to handle. So I want to do a different way of simplifying this. I want to use polynomial long division is what it's called to see if we can get the same result. So we're going to get into polynomial long division, which is really, really similar to numerical long division that we all had to learn in maybe second, third, fourth grade. The steps are a little bit different, but the process is the same overall. So we're going to set it up with our denominator going into our numerator. So we have x plus 5 going into this quadratic. So we're always going to start with our first term, which is just x. We're going to ignore the 5 for now. How many times can x go into x squared? Well, if x times x is x squared, that means x can go into x squared x times. Take a shot for how many times I say x during this video. You might not survive. So now we're going to do the thing we're used to doing. This is something that applies to numerical long division as well. So we take this result, we're going to multiply it by everything we have in the divisor or the dividend. I always get those two mixed up. But my point is we're going to multiply it not only by the x, but by the plus 5. So we're going to do x plus x times x, excuse me, we're going to do x times x, we get x squared. And then we're going to do x times 5, that's just going to be a plus 5x. And then this is where we do the division. We have to divide when we get to this step in numerical long division, and the same thing applies when we're doing polynomial long division. So we're going to do x squared minus x squared. That just goes away completely. And then we're going to do 7x minus 5x, so we get 2x as our result. So the next thing we want to do is we want to ask ourselves how many times can x go into 2x? And the answer would be twice. It would go in positive 2 times. So we're going to put a plus 2 right there. Then we're going to repeat. So we're going to ask ourselves, how many times can 2 go into x plus 5? Oops, my mistake. I meant to ask the question, what is 2 times x? We're actually going to be dividing this time. We're going to be multiplying this time. What is 2 times x? So we get 2 times x is 2x. And then I forgot to bring this 10 down. So this part applies in numerical long division, and it also applies in polynomial long division as well. So now we're going to do 2 times 5. We already did the 2 times x. Now we're going to do the 2 times 5, and we get positive 10. So we're going to subtract once again. So notice how everything we have on top is identical to everything we have on the bottom in parentheses. So because of that case, we know anything minus itself is automatically going to be 0. So we found our answer, and it is exactly the same as the one we got when we factored. So that's how we know we did this right. So let's try a bit more of a complicated problem. Now that you saw that last example, I invite you to pause the video, give this problem a try, and then see if you can successfully get the correct answer. So I'm going to start with x into 4x cubed. I'm going to ask myself how many times can x go into 4x cubed? The answer would be 4x squared. Then we multiply by x. Then we multiply 4x squared by -1. We get the following. We get 4x cubed minus 4x squared. So it's always a really good idea to put parentheses there because we're subtracting it. Without the parentheses, a really common mistake people make is they forget that this is a minus. So a negative and a negative cancel out. We're actually adding 4x squared in this case, but a lot of people, they forget to distribute the minus to this other minus, and they end up subtracting 4x squared when they should actually be adding it. So it's always a really good idea to put parentheses there, just so you make it super clear that we are actually distributing the negative and subtracting the entire binomial from whatever occurs at the top. And I'm going to try not to forget bringing this stuff down this time. So we're going to do this minus that gets us 0. And then we have negative 2x squared minus negative 4x squared, which is equivalent to negative 2x squared plus 4x squared. We get a total of 2x squared. And then I'm going to bring down our plus x and our minus 3. All righty. We want to ask ourselves how many times can x go into 2x squared? That would be 2x. So we're going to do plus 2x. And then we're going to do the multiplication once again. 2x times x gets us 2x squared. And then 2x minus 1, 2x times -1 is going to be negative 2x. Parentheses, subtract. And we get 0 for this 2x squared minus 2x squared. Then we have x minus negative 2x, which is equivalent to x plus 2x which is 3x. I'm going to bring the negative 3 down. We get 3x minus 3. All right, we're getting somewhere. We're near the end. So we're going to do it all over again. We're going to do another iteration. So x can go into 3x. That would be 3 times. So 3 times x is 3x. And then 3 times negative 1 gets us negative 3. So this is similar to what we had in the last example. We have something on top minus itself. So whenever we have that situation, we just get 0. We have nothing left over. So our answer is this. And let me just remind you guys why this is such a powerful tool. So before I put it in long division format, it looked like this. We had some cubic polynomial on top divided by this. So it's a really, really powerful tool because what I drew in this first box is equivalent to what I drew in the second box. So these two are equals of each other. And that's why it's such a powerful tool. We're able to convert this crazy looking thing, this thing that I really wouldn't want to deal with, into some simple expression with just 3 terms and no fractions. So that's why it's such a really powerful tool to have at your disposal, especially down the road if you want to become, like I said, if you want to become a scientist or an engineer, you're going to be needing to take things like calculus 1, 2, and 3, differential equations, maybe even partial differential equations. You've got some linear algebra. This is just an overall useful tool to help you with things like this. So this one worked really, really well because we have a 0 as our final result. There are going to be some cases where we don't have such a nice result. We're going to get some kind of a remainder. So I thought it would be a good idea for us to try one of those types of problems out. So just like with the last one, I invite you to pause the video, give it a try, and see if you get the right answer. So we're going to start this the same way we've started all the rest of them. We're going to do x into 3x to the 4th. So x can go into 3x to the 4th, 3x cubed times. So we're going to multiply. And then we're going to multiply by 2. We get 6x cubed. Parentheses and subtract. So this is going to cancel with that. And then we have 7x to the 3rd power, 7x cubed, minus 6x cubed. So we get just one single x cubed. And I'm going to bring everything else down. So let's do another iteration. So x can go into x cubed an x squared number of times. We multiply now. So x squared times x gets us x cubed. And then we have plus 2 times x squared. That's going to be 2x squared. Parentheses, subtract. We get a result. This is going to turn into just 1x squared minus x minus 4. So then x can go into x squared x times. So we're going to do plus x, multiply. X times x is x squared. I think I can make that look a little bit neater. And then we're going to do plus 2x. Parentheses, subtract. We get 0x squared, and then this is going to turn into negative x minus 2x. We get minus 3x. Bring the negative 4 down, we get minus 4. All right, we're almost there. Now we're going to do x into negative 3x. How many times can x go into negative 3x? That would be negative 3. So we're going to multiply our coefficient or our constant by x and then by 2. So negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Parentheses, subtract. So the 3x's are going to cancel. But what we have over here, this is going to turn into a negative 4 plus 6. We have negative 4 minus negative 6, which turns into a plus 6. Negative 4 plus 6, of course, gets us a value of 2. And we can't really do anything else with that. So this is where things get a little unorthodox. This is where things get unusual. So this is still going to be our answer, but not the entire thing. It's just going to be part of our answer. The rest of our answer comes by putting this over our divisor, if I'm even saying that right. It's either the dividend or the divisor. So our final answer should be this polynomial right here. and then we're going to add to it. This is something we didn't do in the last one. We're going to add to it our final result here at the bottom, which is 2. And then we're going to put 2 over x plus 2. So we still have a fraction. We didn't have a fraction in the last 2 examples we did, but I'd still much rather deal with this than the fraction form of this. It's still much, much nicer to work with. I think we're going to do one more example. So we have a new problem up on the board. Just like last time, I invite you to pause the video, give it a try, see if you get the right answer. Let's see if I still remember how to do this, because I was going crazy figuring out if this was the divisor or the dividend. And then I remembered that there's actually a Simpsons episode where the mob leader in the town, Fat Tony, has a kid, and he's reminding his kid that this part is actually the divisor. He says, remember, the divisor goes into the dividend. And like any reasonable person would, I decided, instead of just Googling it real quick, I decided to watch the entire episode because, like I said, that's what a reasonable person would do. So let's see if I still remember how to do this, or if I've just killed my streak. So we're going to start just like we've started all the rest of them. We're going to figure out how many times this first part of our divisor goes into this first part of our dividend. So 3x can go into 9x to the 5th, 3x to the 4th times. So we're going to multiply like before. We get negative 15x to the 4th, parentheses, and subtract. So this is going to turn into a plus 15x to the 4th. We're going to get 6x to the 4th. And then I'm going to be really lazy and just bring everything down like this, because you would expect nothing else from me. So now we're going to do 3x into the 6x to the 4th. So 3x can go into 6x to the 4th, 2x cubed times. We're going to multiply them. We get 6x to the 4th. And then this is going to turn into a minus 10x cubed. Parentheses, subtract. We're going to get negative x cubed plus 10x squared, plus 10x cubed. And then that's going to turn into positive 9x cubed. And then just like before, move this all down. So 3x can go into 9x cubed, 3x squared times. So 3x squared times 3x is 9x cubed. And then 3x squared times negative 5 is negative 15x squared. Parentheses, subtract. We get negative 12x squared plus 15x squared. That turns into a 3x squared. And then I'm going to bring down this stuff. So 3x can go into 3x squared x times. So we're going to do a plus x. 3x times x is 3x squared. And then we're going to do x times negative 5. We get a minus 5x. Parentheses, subtract, and we get x plus 5x squared. X plus 5x gets a 6x. And at this point, it would be just extreme laziness if I brought this negative 11 down. So I'm just going to, I guess, start writing it like a pleb. So 3x can go into 6x squared twice. So we're going to do 3x times 2, we get 6x. And then we're going to do 2 times negative 5, we get negative 10. So normally I do that thing with the parentheses, but in this time I don't really see a point because we're dealing with something really small. So I'm not going to make this a negative. This is going to be a plus. So the 6x's are going to go away. And then we have negative 11 plus 10, we get negative 1. So that means our final result is going to be this thing we get on the top, plus our remainder over our divisor, which happens to be 3x plus 5, 3x minus 5. There you have it. That's polynomial long division in a nutshell. So keep your eyes peeled for the next video on this particular kind of lesson. The next topic is going to be covering synthetic division, which gets us the same result, but it's just more useful in certain situations. Now, I don't want to promise you a date. I just will say it is coming in the future. Might come tomorrow, might come in a week, might come in a year from now. My procrastination knows no bound. So see you in the next video, guys.